Hey everybody, today we're going to solve some linear systems. We're going to talk about what that means in a second, but we're going to use the substitution method or the substitution strategy. So think about when you're in volleyball or soccer and they put their hands in and they tag in and the ref's got to check them in, or they hold up that in and out sign over there in soccer in the official games and swapping in number 12 and coming out number 3. Same thing happens in Frisbee. You can sub in a bunch of sports. So yeah, just kind of use that idea of swapping, plugging in, subbing in for today. Okay, cool. What is a linear system? A linear system, think about the solar system. The solar system has multiple parts. It's not just the soul. It's not just the sun. The respiratory system is more than just your lungs. It's your nose. It's your mouth, it's your lungs, it's all those parts that are connected to breathing. So it just has multiple parts. So linear system just has multiple parts, has multiple equations. So how do we solve for these two equations? I mean, technically like y is solved for over on the right side, but it's not a number. So think about visually what's going to happen. When we graph one line, when we graph another line, we're going to be finding the point of intersection. So we need to use these two equations to find the point of intersection. Cool, so using the substitution strategy, we're looking for is one of our variables solved? And we do, we've got y solved for. So what we're gonna do is we're gonna take this equation and we're gonna sub it in for that y. Sub it in, substitution, there you go. 6x plus 3. Instead of writing the y, I have a different y written over here. So instead of that, I'm going to replace the y with 4 minus 3x. I continue the rest of the equation, which is equal to 18. All I really need to know now is how do I distribute or multiply. So we got 6x plus, now that's a 12, now that's a minus 9x, and I continue the problem. We can just go ahead and combine some like terms here. That's going to give me negative 3x plus 12, and I can get rid of the 12, and I got negative 3x is equal to 6, and then I divide, and I'm just using middle school math at this point, and I get x equals negative 2. Cool, that means on the graph these points are going to intersect, these lines are going to intersect at the point of negative 2 comma something. Well, how do I find the y? Well, how about using this y equals equation? We just solved x is negative 2, so now we're going to sub it back in, substitution. Notice how whenever I have an x, I'm going to use parentheses when I'm subbing in, the same way on the left that I used parentheses when I subbed it in. Y equals 4. Negative 3 times a negative 2 is positive 6, so my y is equal to 10. Now, if I wanted to go above and beyond, I could take this other equation and I could have plugged in the negative 2 for x, just to make sure. I don't have to, but I'm going to, just on the first one here. And I could have plugged it in, and this could also have solved me for y. There we go, divide by 3, and y is equal to 10, and there's just double proof that I did that problem correctly. So that looks like a ton of work. We don't have to do all of that every time. I figured I'd just show it in case you would like to do that later. All right, so I've got 5x minus 2. I'm going to go ahead and sub in the y. Why? Because the y is solved for. So I'm going to plug in the same thing. These are both equal. The y is equal to 2x minus 1. So instead of y, I'm writing 2x minus 1. They're equal. I'm allowed to do that. I've got 5x. Now I have a negative 2 distributing, which will give me negative 4x. Now I have a negative 2 distributing to another negative. That's going to be a positive. And then I just combine like terms. There's my x plus 2 equals 6. Get rid of the 2. And I'm just doing that middle school math. X equals 4, so in my solution, I'm going to get 4 comma something. I could plug the 4 back into this x up top here, but I promise it's going to be easier. If you're trying to solve for y, just plug in the equation that has the y already by itself. For the x, I need to plug in the 4. I just solved for that. Y equals 8 minus 1. Y equals 7. There's my point of intersection. Cool, let's wrap it up with one that has fractions, but also has an x equals. Watch how I sub it in. All right, 1/2. I do not write the x because the x is what I have solved for. In the last problems, it was the y, so I subbed it in for the y. Here I have x, so I'm going to go ahead and sub in for the x. Now, why have we been doing this, right? Well, take a look at this original problem here. You can't solve x or y when they're both in the equation. But now, in the second equation, when it's all y's, now I can solve for y. So I distribute the 1/2, that gives me 2y. I distribute the 1/2, I'll go to decimals, write the rest of the problem, combine some like terms here, get 3y plus a decimal, get rid of that decimal, and we're just following along the middle school math at this point. Divide by 3, use your calculator if you need to, but if you have 4.5 cut into 3 chunks, that would be 1.5. Watch when I go to my point now that I'm writing the y over in the y spot, not in the x. So it's not guaranteed I always get the first part of the point. Solve for y, guess what? Now I'm going to plug it in for y. We're subbing it in for y. X equals, if I got 4 chunks of 1, that's 4. 4 chunks of 1/2, that's 2. That gives me 6. And that gives me my answer of 9. If I went ahead and graphed these lines, I would get the point 9, 1.5. That is how you solve linear systems, which are multiple lines, using the strategy of substitution. Sub it on in.